Hello again, my fellow pilots and my fellow aircraft maintenance personnel. Your host is always Haitham Ali, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today we are going to discuss the normal, alternate, and direct flight control law in the Airbus A320 family. From this schematic, you can see an example of an electrical flight control system computer. This may be ELAC. This may be SEC. Okay. For fly-by-wire philosophy in the Airbus A320 family, thanks to the fly-by-wire philosophy, pilot input will always be interpreted inside a flight control computer. And before giving the input to the surface for surface deflection, the flight control computer computes the pilot input or even the autopilot input using three types of law: normal law, alternate law, or direct law. Okay, so what is the best? The best is normal law. Come in second, alternate law. And the final one is direct law. Normal, alternate, and direct are electrical signal. If we have normal law, alternate law, or direct law, so we have electrical signal and electrical control going to the surface. So yes, normal, alternate, or direct is a fly-by-wire philosophy. Fly-by-wire control. What is the difference between normal, alternate, or direct law? Normal law give full flight envelope protection. Alternate law give some protection but a reduced one. Direct law, there is no protection will happen, so that you can imagine the electrical flight control system computer as a wire. Not a computer, just passing the signal or the input. If direct law, no protection, pilot input through direct law, same, going to the surface deflection in a form of electrical signal, But normal or alternate law, there is a protection happen. The pilot input may not reach the same as it is out of limit, may take the aircraft into problem. Okay, so the fly-by-wire philosophy or fly-by-wire control, it's called electrical flight control system. So for flight control law, the electrical flight control system computer convert pilot input into aircraft control objective. Again, the electrical flight control system computer convert pilot input into aircraft control objective. And the prevent electrical flight control system computer prevent aircraft excessive maneuver. Prevent aircraft going to, for example, stall. Prevent aircraft from going to overspeed, high bank angle. All these protection are available in normal law, which provide all protection, Okay, everybody. Okay, so the computers calculate the control laws that are used to compute the surface deflection. The computers calculate the control laws that are used to compute the surface deflection. So the control law, normal or alternate or direct, used to compute surface deflection. Actually, the computer either controlling normally or alternate or direct. Actually, the computer is the one who sends the surface deflection. Computer calculates the control law that are used to compute the surface deflection. So everybody, when we always have normal, when we can degrade to alternate, and when we can degrade to direct law, from normal to alternate or from normal to direct, who control this degradation? So as you can see here, electrical flight control system control law switch from normal to alternate or direct according to the nature and the number of failure. Nature and number of failure. So if the aircraft is good, no failure are there. So pilot satisfy from normal law inside the electrical flight control system computer, and all protection will be available. But if some failure happen, like dual hydraulic loss, for example, so that always the electrical flight control system computer are in need to the hydraulic system status, green, blue, or yellow system. Okay, so if some failure happen, normal law cannot be computed, so that alternate law will be available, or even direct law. So we can convert from normal to alternate, or even from normal to direct law. So again, the computer calculates the control laws that are used to compute the surface deflection. Okay, everybody. So the system has a high degree of redundancy, and it will reconfigure itself when failure occurs. So reconfiguration from normal to alternate or from normal to direct happen automatically thanks to the redundancy of the system. So again, the system has a high degree of redundancy, and it will reconfigure itself when failure occurs from normal to alternate or from normal to direct according to the nature and the number of failure. Okay, everybody. So in normal condition, the normal law is used to compute the surface deflection. Orders. Normal law provide full flight phase envelope protection. All protection are available if normal law is being computed. This means that the aircraft will be protected from excessive maneuvers during all flight phases. This is the meaning behind the normal law and the meaning behind all protection available. Again, what's meant by all protection available? This means that the aircraft will be protected from excessive maneuvers during all flight phases. Okay, so if the aircraft status is great, no failure, normal law is used to compute the surface deflection, and normal law will provide full flight phase envelope protection. Okay, so the alternate law is automatically introduced as soon as the normal law is lost due to system failure. So what takes us from normal to alternate? System failure. What takes us from normal to direct? Systems failure. And the alternate law gives protection, yes, but a reduced protection. Again, the alternate law gives reduced protection. If the aircraft status is very bad, so you will go from normal to direct. With no protection. Direct law, no protection. Okay, everybody. So, as you can see here, the direct law is automatically introduced when further failure occurs. In direct law, all protection are lost. Direct law, no protection. There is a direct relationship between the side stick orders and the surface. So that it's called direct law. If you ever been asked what's meant by direct law, now it is a direct relation by or from the pilot input to the surface deflection. No protection or no intervene from the electrical flight control system computer. No protection or no intervene from the electrical flight control system computers. Okay, so the direct law is automatically activated on grounds. On ground, even if the aircraft status is great, we don't need normal law, we don't need alternate law. Always on ground, there is a direct relationship between the side stick or pilot control and the surface deflection Generally, to allow the pilot to check flight controls before takeoff, to bring the flight control system to the extreme and check the surface deflection before takeoff. So again, on ground, even if the aircraft status or even if the aircraft is in great condition, there will be always direct low computed by the electrical flight. No, sorry, it's not computed. It's introduced by the electrical flight control system. Direct low, direct relation between the side stick or pilot control and the surface deflection. Only in case of total computer failure, case of all flight control computer failure or aircraft electrical power loss, we cannot have fly-by-wire. So only in that case we still have a hope, because the rudder and the THS rudder and the THS can also be mechanically controlled by the trim wheel to control the THS and the pedal to control the rudder. So we have a mechanical connection and a mechanical linkage, direct linkage mechanically from the trim wheel until the elevator THS, so the trimmable horizontal stabilizer actuator, and from the pedals until the rudder. So the mechanical backup lets the aircraft be controlled during a temporary complete loss of electrical power or flight control computer. Again, the mechanical backup lets the aircraft be controlled during a temporary complete loss of electrical power or flight control computer. So yes, in the Airbus A320 family, we have fly-by-wire. Great fly-by-wire philosophy for flight controls. But in case no electrical power, no flight control computer, we still have a hope like fly-by-cable. From the trim wheel until the THS, trimmable horizontal stabilizer, and from the pedal to the rudder. From the pedal, so lateral and longitudinal control can be achieved mechanically in that case. So don't confuse my fellow pilots and my fellow aircraft maintenance people between direct low and the mechanical control. Direct low and the mechanical control. Direct low still fly-by-wire. Again, as you can see here, direct low still fly-by-wire from the input to the surface. Direct low still fly-by-wire, but without protection. Direct relation between the pilot input and the surface deflection, but still fly-by-wire. Mechanical backup, it is not fly-by-wire. We revert from fly-by-wire to fly-by-cable. We revert from fly-by-wire to fly-by-cable. Thank you always for your good listening, my fellow pilots and my fellow aircraft maintenance people. Your host is always Haytham Ali, your aviation technical instructor. Before I finish, I need to tell you and emphasize that this is for a performance support tools. This session for performance support. It is not a formal training. It is a performance support session to increase your awareness, to increase your behavior, to increase your understanding to the aircraft systems. For flight and for aircraft maintenance, always refer to formal manuals like Flight Crew Operating Manual, Aircraft Maintenance Manual, and Formal Training Manual. From Cairo, Egypt, your host was Haytham Ali, and I'm an aviation technical instructor. Thank you, have a good day, and please stay tuned for an upcoming session like this. Thanks!